Alright, guys.
So yesterday, I was going to say last time, really yesterday, we got into something that was very exciting. Everybody loved it. So if you weren't here, get ready. Yesterday we did this kind of thing. I promised you a shortcut, and I will show you the shortcut. But let's do this the long way first. In fact, let me do this. Do I want to do that? Yeah, let's do this. Everybody make this an x squared. Okay. Can somebody tell me how I know this is going to go in? Like, how do I know 11/8 is going to have a whole part, but 8/11 won't? It's a dumb question, but you guys with me? Why is 11/8 going to have a mixed number, like a whole part, and an 8/11 wouldn't?
The numerator's larger.
Yeah, the top's heavier, right? Do you see how the top's heavier here? Higher degree? So I know that long division will actually give me something. So just to remind you guys, if you weren't here yesterday, first thing I had people do was long divide something, which is always very exciting. So how do you start this off, for example? Yeah, I look at 5 into 26, yes? That's what we do. If you really did this in earnest and caught what you were doing, you say, okay, that's what I did. 5 goes into 26 how many times?
5 times.
But when I multiply, I'm not just going to multiply by 5, I'm of course going to multiply by the 1 also, right? And then I change the sign and combine.
Where did that second 5 come from?
5 times 5, 5 times 1. I'm doing 5 times 51. Is that cool?
Mm-hmm.
Okay. Then I get 14, and I bring down the 8. 5 goes into 14 how many times?
2 times.
2 times. 2 times 51 is 102. Subtract, I get 46. So that would say, and 46 51sts, yes? And of course, we talked about the fact that it was a really bad decision. I think everybody in the room was probably blitzed, and they said, yeah, let's just take the plus out. Yeah, that's great. It was a bad decision. We normally write a mixed number as like 7 and 8/11s. They're next to each other. But that means multiply everywhere else except at one time. Okay. You guys all kind of with me? I know you haven't done long division in a long time. That's why I like to show it to you, because we do all the same steps. So let's see. If I write this in long division form, can somebody see a problem up here with this guy? Is there a problem with him? He doesn't have x's. How many x's would you say he has? He has 4x squares, he has 1x cubed. How many x's?
5.
Where are 5 x's? He has 1x cubed, yes? He has 4x squares.
Yes, no.
How many x's does he have?
No axis.
And you're like, I don't know him. I don't know what's his. No. How many x's? He's got 1x cubed. Is everybody with me? He's got 4x squares. Is everybody with me? How many x's does the top have?
No.
Why does everybody keep saying 5?
No
He has
X.
none. He has 0. Do you see an x term up top? Do you see an x cubed term up top?
Yes.
Do you see an yes? Do you see an x squared term up top?
Oh, like just an X.
Do you see an x cubed term? Yes. Do you see an x squared term? Yes. Do you see how? So he's got 4x squares. Yes. He's got 1x cubed. How many x's does he have? 0. So the one difference between polynomials and normal numbers is if I wanted to say 1098, I wouldn't do this. I would put a 0 here to represent I have 0, 100. So when I do set this up, I have to put a 0x here to hold that place. Come a 3. So how did I get a 5 here? 5 times what is 26? 5 roughly, right? So x squared times what is x cubed?
X.
X. X times x squared is X times negative 1 is. Now, where am I going to put negative 1x, do you think? I'm going to put it here?
No.
That would make no sense. And then what do we do? We change the signs. Change the signs. Every step is the same. These cancel. This just comes down because there's nothing to do anything with. And this would become, and then I bring down. Every step is the same. Every step is the same. X squared times what is 4x squared? X squared times what is 4x squared? 4. 4 times x squared is 4x squared, like we just said. 4 times negative 1 is, where do I put it? Under the 7. And then I change the signs. Now, can you guys see that if you had to guess, can you see how it would be a good guess to tell that the mistakes people are going to make, one big one is going to be to forget the change of signs? The shortcut I'm going to show you that is stupid powerful, but because it only works sometimes, the first thing it does is it changes the signs first. So you never have to do it again. You don't have to remember it each time. They just say, screw it, change the sign first. So you'll see. So what do I do with this stupid thing? Well, what do we do with this stupid thing?
The remainder.
Yeah. So it'll be plus x minus 3 over. Good. Okay.
Where did the x squared 1 come from? Oh, wait, I just found it right.
Yeah. Just like we do with numbers, remainder over the divisor, right? We don't put the big ass R. We're not in second grade. Okay.
What's the case that we always do for terms?
No, we don't always need 4 terms. We just need to have every possible position represented. So if I had x to the 5th minus 2, I would write x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x plus whatever number I said.
Where did the plus 1x come from?
Oh, okay. Where did the 255 come from?
5 times 15.
5 times 51. So where did this come from? X times x squared minus 1. X times x squared is x cubed. X times negative 1 is negative 1x. And then we change the signs. Whatever I put here, I multiply by this. Whatever I put here, I multiply by this.
Wait, no, but you have. Oh, never mind.
I change the signs. Yes. Okay. So here, you guys try a very specific one that's going to come back later. You guys try this one. Yeah, this one. Here, I'll give you one that you don't have to worry about. Is everybody represented up top there? So you don't have to worry about adding a 0, but you do have to be careful. Just you want to be nice to yourself. So go ahead and try to do that long division. This is where you start to realize in 176 and above, sometimes you might actually have to turn your paper this way. You might have to turn your paper whoop, just to fit everything up. Not quite yet, but you can imagine that might happen. Something kind of nifty should happen. Do you guys like the amount of writing it takes to do this? Alright, if you did, I'd be like, what the shit? I don't like it either, but that's what I'm going to show you the shortcut in a minute. There's a lot of writing we do that's kind of dumb. It's repetitive. Oh shit, Jeff. Damn it. It's my fault. It's alright. I'll be okay. That should have been a -7x squared, but it's okay. We'll do it like this. We'll be fine. So nothing nifty will happen. You know? This could get kind of gross. I don't know. Does it get kind of gross? I'm sorry. All right. Here. I'll do this with you. X times what is x to the 4th? X cubed. X cubed times x is x to the 4th. X cubed times 3 is 3x cubed. And then I
Cancel.
change the signs. These cancel. -4 minus 3 is -7. Bring down to 7. X times what is -7x cubed? X times what is -7x cubed? Good. You need -7 and 2 more x's. So you get -7x cubed minus 21x squared. Change the signs. This is okay, 28x, nobody's playing along. And then bring down the 34x, Jeff squared. X times what is 28x squared? X times what is 28x squared?
28x.
X times what? Yeah, 28x. 28x times x is 28x squared. 28x times 3, this gets gross, is 84.
Yes.
Change the signs. It's not as bad as it could have been. Let's see, -50x. Bring down the -24. Oh, this is not bad. I thought it was going to be like hundreds or something. Is everybody with me? Does anybody see how you keep doing like the same 3 things over and over and over and over and over? So once you see it, once you see one thing, you just gotta do it again, again, again. This is so fun, Jeff. It's so good. X times what is -50x? X times -50. -50 times x is what we just said. -50 times 3 is -150. Then I change the signs. These cancel. I got 126. Okay, that wasn't bad. Listen to you guys. Whatever. Alright, now if you got lost in the sauce, I mean, it's really easy to make a little sign mistake, or you add 8 and 2 and get 9 or something. You know, these things happen. Now, real quick, let's kind of pick this thing apart. Isn't it dumb to keep writing this dumb thing? You see how whatever shit this is, it's just going to cancel, yes? So that's kind of dumb. Isn't it dumb to keep writing all the x's, because all that really matters is the coefficients? Do you guys see that? All I need are the coefficients of the answer. Yes? And you see, I keep getting them from -4 minus 3. That's why there's a -7 there. 7 plus 21. That's why there's a 28 there. So the shortcut says, all right, let's get right to that. Let's get rid of all the shit we don't need. All I care about are the numbers. Yes? I really hate that I made that stupid sign mistake. God damn it. All right, look. Yeah, okay, let's do it. I got it. Okay. I'm going to redo this problem, but I'm going to do the shortcut. And I want to reference stuff that we did here. Here's the shortcut. Okay, let me rewrite the problem. The shortcut only works if the bottom is x plus or minus numbers. If that first problem we did was x squared minus 1, the shortcut don't work. If the bottom was 3x minus 7, the shortcut does not directly work. If the bottom is x cubed plus 8, the shortcut ain't gonna work. Yes, it only works directly if it's x plus or minus number, and that's what we got. And that's what happens a lot in mathematics, so the shortcut ends up being a good shortcut. So the first thing the shortcut says is that all this x shit does not matter. I just need to know the coefficients of the answer. So real quick, what are the coefficients of the answer here? 1, -7, 28, -50, 126. Yes? So if I just knew those, and I really want you guys with me, what was the degree of the top before? What degree is it? What's the highest power? Fourth. Doesn't it make sense if I'm going to divide a fourth degree by a first degree, my degree should go down by 1? Okay. So if I just knew the coefficients and I knew what the original degree was, I could put 1 in front of x cubed, -7 in front of x squared. Yes?
So you said what you're dividing by has to be x plus or minus some other number. Does it also what's not the quotient? The thing that you're dividing, doesn't it have to have powers that decrease by 1?
Yeah, it has to be in order. Yes.
Okay.
So this has to be decreasing order. You're right.
So if you're missing an x squared or 7x squared, then you can't do it.
No, you just put a 0 there.
Oh, okay.
Yeah,
Okay.
so the same thing you would do here, just put a 0 there. Okay. So here's how this works. I love this shit. What are the coefficients of the, and real quick, like you just said, it's a really good point, but I don't think they do this to you, but in general, you gotta be careful. Is this in decreasing order? Yes. What are the coefficients? Just tell me the coefficients and put them like around here. You leave a little room over here. 1,
-4,
-4,
+7,
7,
34,
34,
24.
-24. Now, real quick, I'm divided by x plus 3. And what I'm doing, do you guys see how I'm just kind of removing the variables? I'm just going to look at the numbers. You guys with me? What do I get if I remove the variable on the bottom? What's the only thing left? 3. And what did we just say earlier? It would be great if I didn't have to change the damn sign every time. Let me just change it once. You guys, does that make sense? Changing the sign every time is easy to forget, and then the whole thing goes to shit. Yes? So thankfully you have a teacher that's not Scantron. Because if you have a Scantron math teacher, you don't have a math teacher. So 3, I'm going to take all the x shit out. So there's a 1, there's a -4, I got all that. That's 3. But what I'm going to put is -3. I'm going to change its sign once instead of every damn time. So I'm going to put, I don't like hockey, but I call this a penalty box. I'm going to put -3 over here. This is just the format. You'll see. Now, can somebody tell me, why was there a 1 here? This is kind of a stupid question. Because x times what was x to the 4th? There's a 1 here, so of course there is a 1 here, yes? If there was a 4 here, wouldn't there be a 4 here? Do you all agree that whatever number is here would end up in the answer?
Yes.
So that number is part of the answer. Now let me just do this and show you how it relates to what we already did. When you put this here, didn't you do 1 times 3? Is 3, and then we change the sign? But didn't we already change the sign at the beginning? So watch this. So then we do -3 times 1 is? -3. -4 minus 3 is? Multiply, add. Multiply, add. Now look. -4 minus 3, right? -4 minus 3 is -7. -4 minus 3 is -7. We are getting the coefficients. Multiply. -3 times -7 is? Positive 21. 7 plus 21 is? 28. 7 plus 21 is 28. Do you guys see that? We're just picking out the most important shit. Look at all the shit we wrote. Look at it. Just gaze upon it. If I added a couple more terms, screw this thing. You'd have to be taping paper, and I've done that before. I've actually taped papers together and said, just unroll it so you can grade my work. It's insane. -3 times 28, we did that already. That was 84, right? Add, multiply, add. Did we get the same coefficients? What was it to begin with, the power? 4th. So this is going to be the coefficient of x cubed. And then you just go -7x squared. Plus you just go down in order. And then the last term is going to be the remainder term. There's another way to look at that little negative 3, dude. What kind of shift would this be?
To the left.
To the left 3, yeah. So there's another kind of way to look at it, but I prefer to look at it, well, the real reality is we are changing the sign once instead of every damn time. How you guys feeling?
Will the last term always be the remainder?
Last term is always the remainder. So, real quick, can you guys do this problem the way I meant to, but do it the shortcut way? Put a minus here. So try to set up the, oh, I haven't told you what this is called yet. You'll appreciate this. This process is called synthetic division. So try to do synthetic division to this. Did you get it right this time, Jeff? Yes. Something interesting should happen. The numbers should be easier for one thing. I'm going to start to catch up to you. So bring down the first two, whatever it is. Multiply, add, multiply, add, multiply, add, multiply, add. So what happened that's rather intriguing. Yeah, what's 0? What do we say when we have a number that goes into another number, remainder 0? It went in evenly? You guys say that over? So listen, does 7 go into 56 evenly? Does it go in with no remainder? Does 7 go into 56 evenly? Why? Because 56 is 7 times 8. So if I divide and it goes in evenly, I have found a way to factor it. Let me say this again. If you divide 56 by 7 and it goes in evenly, you have discovered a way to factor 56. Yes? 56 is 7 times 8, because 7 went into 56 8 times evenly. Did this go into this other thing evenly?
Wait,
Sorry? Go ahead.
how'd you get minus 42?
14 times negative 3.
Oh.
Right? Bring it down. Multiply, add, multiply, add, multiply, add. So what did we just discover? We just discovered that this can be factored as x plus 3 times, and what is all this here? What is this? X cubed, good.
Minus 7x squared plus 14x.
We have factored this thing, which before today, we could not do. There's no way in hell we could have factored this damn thing. Do you guys agree? I should have started with that. I should have said, factor this, and just given you like a minute, and then said, I'm joking. You can't factor that shit. You can't. You cannot. Yes?
How would you factor that if you didn't know that you're dividing it by x plus 3?
That's the next step, is how do I pick what to divide by? So I was nice here. I gave us the thing that would work. There's more than this thing that would work, but this is one. You're exactly right. But if I know what to try and it goes in evenly, I've discovered how to factor it. And did I impart upon you how important factoring is? So we can't factor much once it's more than 4 terms, or even some 4-term dudes. Like how many terms is this? Bless you.
4.
4. Can you guys see very quickly that grouping would not work? So can we factor this? No. And to be really honest, I'm not really sure if that would work. Oh, it will work, I think. Oh, interesting. Maybe I should show you. I think it'll work. All right, somebody semi with me. Synthetic division is really just long division. But it's a lot easier than long division, and it's a quick way to factor something we could never factor. So, now let's address your question. Okay, math boy, you had an x plus 3 down there given to you. What if I'm not given that shit? What if you just give us this and say use synthetic division to factor this? Which I will do. What do I do then? So let me ask you this. If I have, here, let's look at this guy. This is what was left over, yes? This is that big dude that was left over here. Is that cool? Looking at this. Can you guys tell me if this does factor? Are you guys cool with this would be x, x, x like that? Does that make sense? Does that make sense? If this does factor all the way down, it would have to be x, x. Okay. Can anyone tell me what must be true about the numbers at the end of each of those? Whatever numbers I put in, can one of the numbers be 7? What do you think? Can one of the numbers be 7? No, because what do they all have to make? If I foil, the numbers have to make -8. So what numbers could be there?
-2.
2, plus or minus 2, plus or minus 1. Don't forget 1. Give me some more.
4.
Plus or minus 4, plus or minus 8. The factors of 8. So why when I had 24 at the first one, right? The first one had 24. Why does it make sense that 3 might work, -3, because that's a factor of 24. So, I'm going to let you guys give me can you guys pick a number? It could be plus or minus 1, 2, 4, 8. Pick one of those. 2? Positive 2.
-2.
-2. So I'm going to try to divide this by x plus 2. That's what this represents.
Oh, no, that's not what I wanted then.
You want positive 2?
Yeah.
Yeah. So if I want to divide by x minus 2, remember what I put over here is the opposite sign. So what are the coefficients here? 1, -7, 14, -8. Okay, let's see. How do I get this started? Yeah, bring that down. Multiply. Add. Multiply. Add. Multiply. Add. Did it go in evenly?
Yes.
Cool. How did you figure that out, by the way? Because that's what I thought in my head. I thought, okay, that goes in. Or did you just take
since
a...
it's 3 numbers, -2 times -2 times -2 is going to be
Oh, okay, good. But don't forget, it could have been 1, 1, 8.
Yeah.
It could be 1, 4, 2. But 2 is a good bet. And if it doesn't work, no problem. I'll just pick another thing. I need you guys, do you start to understand what's going to happen to you? You're going to be given something. And you have to make a list of numbers to try. And I am going to give you ways to cut that list down because it would be really evil for me to give you a test and you have all these numbers and they're all, and you just start trying them and you try and the person next to you is lucky and just pick the right one and you're not lucky. You pick everything that's wrong and you're just wasting time and you're like, and then the person next to you is like, well, that was nice. No, that's evil. So I'm going to give you a way to cut the list down. Are you guys kind of with me? Because this list can get really big based on how big that last number is, yes? And I ain't going to try all the damn numbers.
So
Sorry.
the things that go in the parentheses is +1 minus 5 and +1?
Huh?
Uh,
No. Okay, so what do we know so far? Let me see if you guys cool this. The original thing I had, what do we know so far? By the way, don't freak out if there's a little bit too much going on. I'm trying to throw several things at you at once because they're all related. what was the first thing we got to go in? We got x plus 3 to go in, yes? So that's a factor. What did we just now get to go in?
X plus 2.
X minus 2, yes? And what was left? What was the original power right now?
The X.
Third, so what should this be the coefficient of? X squared. Keep going.
Minus 5x plus 4.
Can you factor this? Yes. See, once you get down to quadratic, it's either factorable or not. You don't need synthetic division's help anymore. Sometimes cubic, if grouping works, you don't need synthetic division. With our cubic we had, grouping didn't work. I needed synthetic division to help me. How do you factor x squared minus 5x plus 4? X minus 1, x minus 4. So what two numbers would have worked instead of 2?
Negative
No,
1.
1, 4. Yes? What are the x-intercepts of our polynomial?
Negative 3.
Do you see how that relates to what goes in the penalty box? Keep going.
2.
2. So what else could I put in the penalty box? 1, 4. So when you divide by a number, you're actually dividing by what the 0 could be. Because you're changing the sign, which is what we do. This all comes back together. I know I've thrown a lot at you. How do you feel about just synthetic division by itself? Even if you don't fully remember the steps, you should be at a point where you're like, that looks a lot better than freaking long division. Okay. So let me give you this. It's got a little more information on it than we've done yet, but it's okay. One side is very applicable.
Down a little. Sorry, my tablet freaked out, so I was able.
Oh, no.
I need to recopy it.
It's not
So
good.
I'm just gonna take a picture.
That's a new. Is that an Apple tablet?
It's an Apple tablet, but it's an older one.
It's got the.
I tried to copy paste something and then it copied on top, and instead of undoing it, it's just like, I don't disappear now, and it's like, please, I can't
The
read
personality matrix where it can freak out. It's freak. If the bottom is x plus or minus something. And I'll tell you this, I reviewed synthetic division with my Calculus 2 students the last 2 classes ago, I think, because they use synthetic division. Just so you know, it's not something we learn here and never do again. This is huge. This is important. This is everywhere. Because how often do I have to factor? Well, if you don't know, all the damn time. Factoring is everywhere. So this is a tool. It's a factor. It's not the only thing it is, but it's definitely that. Let's see. Oh, on here I've got a long division example. This is the problem we did together. So it's here again. And then this is that first thing redone in synthetic division form. You guys with me? One thing I want to say before I get too far. Real quick. What is x minus 3 times x minus 4? What do you get when you multiply those out?
X squared minus 7x plus 12.
Alright, so if I try to do this, do you agree this won't go in evenly?
Right.
Do you see that? Is that cool? But let's see what we get. So if I try to do this, I put 3 there, right? Just stay with me for a second. This is such a cool thing to realize what remainders tell us. Bring the 1 down, multiply, add. What was my remainder? And what is true about the thing? How far away is it from something that would have worked? 1. So the remainder tells you how close the top was for it to go in evenly. That's a cool thing to recognize. Now to be really honest, here I'll show you this too. The remainder tells you one thing more, which kicks so much ass. Can you guys take this function, I'm going to call it f of x. Can you put a 1 into it? Put a 3 into it. Just take a second and do that. Just throw a 3 in, yes? Just do it. Jack. Well, some of you guys are looking like, no, not gonna do it, because you're gonna do it, I don't care. Alright. What do you get, sorry? Interesting. No, you're fine. 9 minus 21 plus 13. 9 plus 13 is 22 minus 21 is? 9 plus 13 is 22 minus 21 is? 1, which is the remainder, which is always true. The remainder tells you if you would have put this number in, you would have gotten this. Anybody find that interesting in any way? Okay, and then, oh, I got time. The reason that's true, stay with me. Last thing for today, because I can feel you guys, some of you, your parts of your brain are already out the door, but stay with me for a second. This is so cool. So when we, you hid this from yourself, Jeff. We just figured out, damn it, where'd it go? What did we just figure out? I don't know where I put the paper. Somebody help me out. We got what answer again when we divided 4? Damn it all, there it is. Okay. So we got this. We got x squared minus 7x plus 13 divided by x minus 3. We got x squared minus 4x plus 1 over x minus 3. Is that cool, guys? That was the remainder, yes? Is that cool?
Wait, what? How'd you get an x squared?
Oh, not squared, I'm sorry. I'm doing this too quick. X minus 4 plus 1 over x minus 3. I looked at the wrong paper for the wrong power. Okay. Is everybody with me? X minus 4 plus 1 over x minus 3. Okay. If I multiply both sides by x minus 3, I get x squared minus 7x plus 13 equals x minus 4 times x minus 3 plus 1. Do you guys see that? X minus 3 times x minus 4. These cancel, plus 1. So when you put a 3 in, what happens to this when I put a 3 in?
You get 1.
No, well, I mean overall, but what happens to this piece when you put a 3 in?
You get 0.
0 plus 1. So that's why the remainder tells you what the output would be if you plugged the number in that you synthetically divided by. That is kind of nice. If it's a 0 remainder, that's the best. I just figured out how to factor it. One way. If I get anything else, it still tells me something, which is nice. It still means something.
Would 0 also tell us our y-intercept?
I mean, to be honest, this 0 also tell you the y-intercept.
So if you get
No.
a remainder of 0.
That just tells you you factored.
Okay.
The y-intercept could still be whatever the hell it is.
Okay.
Yeah. It speaks to the output. Alright, that's plenty. Okay. I'll see you guys tomorrow. What's going on tomorrow?